Example 1 part C. Example 1 part C says that 6x squared plus 13x minus 5 is 0. At this particular point, you can already see that our A is not 1, is 6. So we have our B, and of course AC. Our B is 13, AC is minus 30. Two numbers you multiply, they give you 30 negative, and you add, they give you a positive 13. It goes without saying, one is a negative, another one is a positive, and the one with a positive sign is bigger than the one with a negative sign, such that when you add them up, you'll be left with a positive 13. So this is simply 15 minus 2. And 15 times minus 2, as you can see, the product is given. So you substitute the middle term. We have 6x squared plus 15x minus 2x minus 5 is 0. So between 6x squared and 15x, 3x is common. So 3x is common there. And you divide this by this, you have 2x plus 5, negative 2 comes over. No, negative 2 is not common because minus 5 cannot divide negative 2. So negative 1 is common, such that we have minus 2x divided by minus 1 is 2x. Of course, minus 5 divided by minus 1 is a positive 5. So this one you just have to be equals to 0. Of course, the outer terms who are outside the brackets form their own bracket. 3x minus 1, 2x plus a 5 is 0. And it goes without saying that 3x minus 1 could be the one which is 0. If this is true, x is equals to 1 over 3. Or it could be 2x plus 5 is the one which is 0. And if this is true, then x is equals to minus 5 over 2, or something like that. So that is part C, and you can see how we easily solve it up. And I want us to just understand part D, which is a bit complicated, but we have nothing to worry. So let's see what is in part D. In part D, we have x squared minus 5x plus 18 equals to 2 plus 3x. You can see this one, the right hand side is not equals to 0. And you can see the general requirement of any quadratic equation, so long as the highest power of the unknown is 2, then it is a quadratic equation. And the general requirement of a quadratic equation, by the time you solve it, let the right hand side be equals to 0, as you can see. So everything on the right of this particular equation, we will have to bring it on the left. Therefore, so we are going to rearrange, and we are going to have our problem as x squared minus 5x minus 3x plus 18 minus 2 is equals to 0. The whole of this come to the left, and of course we need to collect the like terms. So we have x squared minus 8x, of course, plus 16 is equals to 0. At that particular point, now we can be able to have our B and AC. You can see our B is minus 8 and AC is positive 16. Two numbers we multiply, they give us 16, and we add, they give us a negative 8. Of course, hint, both of them must be having a negative sign, such that negative times negative will get a positive, and negative plus a negative, we are going to get a negative. So it goes without saying, this is minus 4, And of course, we break the middle term, x squared minus 4x minus 4x plus 16 is 0. Within the first two terms, what is common? X is common. So x gets outside the bracket, is acting like a watchman. Of course, outside the bracket, inside the house, we have x minus 4. And then the other watchman in the other association is minus 4, open bracket. Inside the house, we have x minus 4. Remember, this bracket has to be repeated. They have to be identical. Of course, this is equals to 0. What happens now? The watchmen form their own association. You can see x minus 4, x minus 4. And the ones in the house, x minus 4. Then we have something like that. And this one is simply a case of repeated root. Because you can see this bracket is identical to that one, it could be one of these x minus 4 is equals to 0. If this is true, x is equals to 4. And or x minus 4 is equals to 0 for the other bracket. If this is true again, x is equals to 4. So there is no point of writing x is equals to 4 or x is equals to 4 because both of them are one and the same. So in a nutshell, x is equals to 4. And we will go to construction of graph and you'll see this is a case of repeated roots. So we have had several examples, some of them very particular, and they are going to teach us something special. Moving forward with this topic, you will see exactly why we are talking about this one in a repeated root. So that is it as far as example 1 is concerned. Please take notes. If you have any problem, let me know. All right.